Welcome to the GMAETS41's Basic Mathematics class. In this video, I'll be teaching you how to write numbers in standard form. Now, we could have a number given to you in ordinary form. You can change it to standard form. It's also possible for you to have a number in standard form and change to ordinary form. But our focus more will be how to write numbers in standard form. We might wonder, why is it that we even write numbers in standard form? Okay, now I'm going to tell you why. We have what we call large number. We have what we call small number, in fact, very small number. I'm going to give you an example. Look at this number. Okay, 473, and you see the number of zeros there, 8 zeros. 473, 8 zeros. It's a very large number. A very large number. Pronouncing it sometimes will just take, some length. Okay, what about this? 0.00009324. A very small number. So instead of pronouncing that long thing like that, the long number like that, we can decide to write it in what we call standard form. And that is why you are studying this topic. So the question is, how do you express a number? How do you write a number in standard form? Here on the board I have these notes to guide you. A number written in basic standard form is expressed as this. A point D times 10 to the power of n. That is how we write a number in standard form. So we can take, for example, maybe I give you 2.45, okay, times 10 raised to power 3. This is a number in its basic standard form. I used the word basic standard form because it's important for us to know the values that this A can take. You see, you have A point D, which means that a number in standard form usually will have a whole number part, which is this A. Now, when it is in its basic standard form, this A, which of course represents a number, must be a number from 1 to 9. That is a number between 0 and 10. What am I saying here? For a number written in basic standard form, this A can only be one digit number. That is why I explained or defined it here that A is a positive integer from 1 to 9. So A cannot be 0. A is not expected to be a 2-digit number. It cannot be 3-digit number, even more. A is meant to be 1-digit number from 1 to 9. So we could talk about 1 or 2, 3 or 4, 5 or 6, 7 or 8 or 9. Is that okay? This is very important because somebody may give you something like this. Let's say 312.04. Okay, let's say 9 times 10 to power, alright, let's say 7. Okay? Now someone can also give you something like, let's say, 10.1 times 10 to power minus, let's say, 4. Now, this 312 is not in its basic form. Because looking at this A represents 312 here. Are you following, right? And this 312 is not a 1-digit number. Therefore, it is not in its basic standard form. It's true, the thing is in standard form, yes, because we have times 10 raised to power something, times 10 raised to power something. This 10 raised to a given power actually makes a number to be in standard form. But when we talk about basic standard form, please take note. The number, that is the whole number before the decimal point, must be a 1-digit number, which means this is not in its basic standard form. This one, 10.1, is not in its basic standard form. But of course, this 2.45 is in its basic standard form. When you're given something like this, you may be required to write it in standard form. as if this is not in standard form. Now what we just want you to do is get the whole number part to be only one digit number. Of course, in this case, you move this point from here to the left 2 times, and then you move it to the left once to make it standard. Let's move on. D is a decimal part if it exists. So in this case, our D is 0.45. Here, our D is 0.049. Here, our D is 0.1. That is 1. Is that okay? Here, 0.49. Here, 0.45. So D is simply the decimal part if it exists. I use the word if it exists because I can give you a number now, a whole number, and I have a decimal number to write in standard form, and you would see that the decimal part may not exist. Let us look at this example. Think about this number. Say that I give you, let's say, 500 to write it in standard form. In standard form, this 500 is equal to 5 times 10 raised to the power 2. Now this is our A, alright, the whole number. There is no decimal point. There is no decimal point. It simply means that no decimal digit is there. Because of course, in this case, if I move the point 1 and 2 to get 5.00, this 00 does not mean anything. They are insignificant. So they can go off. Now you see that in this case, 5 times 10 raised to the power 2, there is no decimal part. That is why I use this word. D is the decimal part if it exists. In the one I just claimed, of course, you saw that the decimal part exists. What about N? N is an integer which may be positive or negative. This N can be positive and it can be negative. Just imagine you're giving, let's say, 2.7 times 10 raised to the power minus 8. N here is minus 8. In this case, N is plus 2. Alright, now we've explained what it means to write a number in basic standard form. Now, I would like us to move straight on to the secrets, the principles, the guidelines, the things you need to guide you, things you should be thinking of when you are given a number to write it in standard form. I have 2 major secrets here. Secret number 1. Always remember that any number standing alone is the same as that number times 10 raised to the power 0. For example, if I give you 5, that 5 is the same as 5 times 10 raised to the power 0. This number is standing alone like that. Look at this one, 371. There is nothing like times 10 raised to any power there. As that number is 371, it is the same as 371 times 10 raised to the power 0. Look at this one, 23.048 is the same as 23.048 multiplied by 10 raised to the power 0. Look at this, 0.00792 is the same as 0.00792 times 10 raised to the power 0. So whenever a number is given to you and you don't see anything times 10 to any power, that number standing alone like that is the same as multiplied by 10 raised to the power 0. That is secret number 1. You want to always remember that. Now, under that secret number 1, I have 1B there. So I'm taking this as secret number 1A. In 1B, what are you expected to know? Any number, again, standing alone without a decimal point. And if I give you a number and there is no decimal point there, that number is a whole number. You should take note of that, of this. Such number has an invisible point 0 after its last digit. For example, if you're given 5, this is 5. There is nothing like points, whatever there. It's a whole number. You should know that this number 5 is the same as 5.0. What about 371? It's the same as 371.0. Does that make sense? So if I give you any whole number, please remember that whole number, there is a decimal point just after its last digit. And we have it as 0.0. You can write it that way. Then we have secret number 2. The last before we take questions. When moving decimal points to the left-hand side, LHS, add the number of times you moved the point to the power of 10. And then when moving decimal points to the right hand side, RHS, subtract the number of times you moved the point from the power of 10. I'm going to give you an example here again. Imagine that I have, let's say, 21.9 times 10 to the power 3. If you look at this whole part is 21, two-digit number. It simply means it is not in its standard basic form. So you have to move points. You have to bring the point between 2 and 1, this way. Now I've moved the points to the left. How many times? Once. This becomes 2.19 times 10 raised to the power 3. How many times did I move the points to the left? Once. So, secret number 2 said if you move it to the left hand side, add the number of times you moved the point to the power of 10. Here the power of 10 is 3. So I am going to add 1 to it because I moved the point once. So that this will now become 2.19 times 10 to the power of 4. What if you move the points to the right? Okay, assuming that I have 0.035, okay, times 10 raised to the power 8. Now, you know that you have to move the point because we need the whole number part to be a number from 1 to 9, not 0. So in this case that you have 0 here, you can't leave it like this. You need to move the point to the right to get this number that is not 0. The point needs to come between these 3 and 5. 1 and 2. So you see you moved it 2 times. So this will become 3.5. No, 003.5. That 00 doesn't mean anything again. Times 10 raised to power 8. Now, how many times did you move the points to the right? 2 times. So you go to the power of 10. According to secret number 2, if you move in the decimal point to the right hand side, subtract the number of times you moved the point from the power of 10. So this is going to be minus 2, which eventually gives us 3.5 times 10 raised to power 6. That is what secret number 2 is telling us. Having explained the secrets you need when dealing with problems, writing numbers in standard form, we shall now pick questions and then solve to see how we can write numbers in standard form. Let us now write the following numbers in standard form. Question number 1. There are 4 of these numbers we are going to write in standard form. 0.00945. We have to write it in standard form. It's actually a simple thing. There's nothing there. All the secrets have been given to you already. So we are going to be guided by the secrets as we solve this problem. The number given to me is 0.00945. This number is standing alone. And so I would like to multiply it by 10 raised to power 0. Now I told you that already. Any number standing alone without times 10 raised to power 0, you can multiply that number by 10 raised to power 0. Good. So this is what I'm now going to do. This will be equal to, I will move this point. You see, the whole number part is 0. And you know that to write a number in standard form, the whole number part is not expected to be 0, and it is not expected to be 10 or even above 10. It's a number that should be from 1 to 9. So for this case, since we have 0 points, you now have 0 something, we are going to move our points to the right. Now, I'll be targeting this digit, this first number, which is not 0. And the number here is 9. I have to move the points to come between 9 and 4. So that the first non-zero digit, the first digit that is not 0 will be this 1 digit, which of course is 9. Let's do that and see. So I go 1, 2, 3. Alright, so this is where the point now is. This will give us 0009.45 times 10 to the power 0. Then how many times did I move the points? I moved it 3 times. Is it to the left or to the right? Clearly you see that I moved it 3 times to the right. And so we are going to minus 3 from the power of 10. This is going to be minus 3. Remember, if you're moving points to the right, you subtract from the power of 10. I can now conclude, therefore, that 0.00945 is equal to 9.45. This 000 does not mean anything because they appeared, before this digit, which is not 0, and then you now have your point. Alright, so I'm going to multiply by 10, then raise to power minus 3. If you have 0 minus 3, it's going to give you minus 3. Answer. Good. Telling you that this 000 does not mean anything. We've actually treated things like this under Sacred Foundation of Mathematics, think number 2 of it when I taught you basic arithmetic, and even when I taught you there is numbers and numeration, the aspect of place values and the rest. Okay, let's move on to question number 2, please. Question number 1, I of it rather. Okay, so we have 864. Again, this number is standing alone, so I am going to write it as 864 times 10 to the power 0. Now, as this number is standing alone, it has a point just after its last digit. This is a whole number. A whole number, there is no decimal point there. Therefore, it's left for you now to remember that for any number standing alone, a whole number, it has a decimal point just after its last digit. In this case, after 4, you have your invisible decimal point. You can write it as 0.0, the choice is yours. But it's a waste of time putting 0.0 there. So from here, we are going to move the point. This time around, look at this is 864. This is a whole number. And you know that for a number to be in standard form, the whole number is expected to be just 1 digit from 1 to 9. It simply means that I'll move the point from here to come between 8 and 6. And for the point to move from here to this place, it will move how many times? Let's find out. 1 and 2. So that's 2 times. This is where the point now is. This is equal to 8.64 times 10 raised to the power 0. Now I move the point 2 times to the left. And so I'm going to add 2 to the power of 10. We can now conclude that 864 is equal to 8.64 times 10 raised to the power 2. 0 plus 2 give you 2. This takes us to II of question number 1. That is III of question number 1. And we have 34.29 times 10 raised to the power minus 6. You see clear that this particular number now came with times 10 raised to the power something. So there is no need of multiplying this number by 10 raised to the power 0 again. No need. I did it for question I and II. I multiplied the number given to us by 10 raised to the power 0 because the numbers were standing alone. Alright, we move. For this question, I will simply move my points directly. Okay, so let's write it here. Equal to 34.29 times 10 raised to the power minus 6. I'm going to move the point, if you see what I have here, once to the left. So that the point would come between 3 and 4. Now the whole number will just be 1 digit number, which is 3. Because I moved this point, of course you know what is going to happen. This will now be equal to 3.429 times 10 to the power of minus 6. The follow come power from the question. Now I moved the point once to the left. Therefore, I'm going to add 1 to the power of 10. I'm going to add 1 to the power of 10. Then I will conclude 34.29 times 10 raised to the power minus 6. The answer is going to be 3.429 times 10 raised to the power minus 5 in standard form. Take note, minus 6 plus 1 is minus 5. We shall take our last question here now, IV. Alright, so we have that 0.06 times 10 raised to the power 8 should be written in standard form. Again, if you look at this question, this number here, it already came with times 10 raised to the power minus, times 10 raised to the power 8. It has its follow come times 10 raised to the power 8, so there is no need of multiplying it by 10 raised to the power 0 again. For this problem, I'll simply rewrite, this is 0.06 times 10 raised to the power 8. I will move the points. Looking at this, I'll ask myself, which direction do I move the points to? Clearly, you move it to the right 2 times. The reason is because you want the whole number to be a digit that is not 0. 1 digit which is not 0. And you can only get that if you move these points from here towards the right. Now, one thing you should take note of is if the whole number part is 0, has 0 points, whatever, in that case you move the point to the right. But if the whole number part in the question given to you, like this one in I, the whole number part is not 0. It is not 0 and it is not in its basic standard form. You move the points to the left. So here, I'm going to move the points 1 and 2, so that this is going to give me equal to 006 points. Alright, then 10 times 10 raised to the power 8. I moved the points 2 times to the right. Therefore, I will minus 2 from the power. So concluding, I have 0.06 times 10 raised to the power 8 in standard form will be this 006. This 00 does not mean anything. So it's simply 6. I have points, there is nothing here, simply 0.0. You can forget about that 0. So this is simply 6 times 10 raised to the power 6. 8 minus 2 is 6, And that is how we solve this problem, writing these numbers in standard form. So you can see that they are very simple. Once you understand all the secrets, that I gave to you, you apply them in solving problems given to you, you will enjoy writing numbers in standard form. Let us just pick 2 more questions, alright? And that will take us to question number 2. And now we have our second question here. Right, our second question, we have A part and B part. Express the following in standard form. A, 345.4 times 10 raised to the power minus 5, correct to 1 dp, that is 1 decimal place. And then B, 0.76 times 10 raised to the power 9, correct to the nearest whole number. Now, you observe that this question, we are asked to get it in certain, number 1 decimal place. Then the B part, we have to get it in whole number. I've taught you the concept of getting answer in decimal places and maybe in whole number. I told you that under one of the secret foundation of mathematics, rounding off. So we are going to apply the knowledge of writing a number in standard form, after which whatever answer we get, we'll now work it out in what they asked us to do, in the number of decimal places they asked us to work it out in. Alright, so question A, I have 345.4 times 10 raised to the power minus 5. This will be equal to, of course, I'm going to write it as 345.4 and then times 10 raised to the power minus 5. There is a follow come 10 raised to the power something there. So no need of multiplying this number by 10 raised to the power 0, since it has times 10 raised to the power of something here. And this is power minus 5. Now looking at this, I'll move the point how many times? 2 times to the left, because the point should be between this first non-zero digit. This first digit that is not 0, the point should be between it and every other digit. Now since the point is here, I'll move it from this position. So we go. This is going to be 1, 2. Alright, so this is where the point is. And of course, this is going to be equal to 3.454 times 10 raised to the power minus 5. I moved the point 2 times to the left, so I will add 2 to the power of 10. Concluding, alright, this is going to give me equal to 3.4 445 times 454 times 10 raised to power minus 5 plus 2 will give us minus 3. Now, I have written 345.4 times 10 raised to power minus 5 in standard form. But the question said I should correct it to one decimal place. So one decimal place means after the decimal point, I should get only what? One decimal digit. I should get only what? One decimal digit. Therefore, what I'm going to do is to round off to the nearest tenths. I've explained all of this in our Sacred Foundation of Mathematics already. I'll now conclude 345.4 times 10 raised to power minus 5 is equal to 3.5. 3.5, because you know you round off, which of course is a rounding up process from this hundredths digit to tenths digit. If you round up to this 4, it's simply to add 1 to this 4, you get 3.5. Then times 10 raised to power minus 3. And this is my answer. Let's move on to the B part of the question. 0.76. Alright, so this is B part B. 0.76 times 10 raised to power 9. We have to correct it to the nearest whole number. But of course, you need to write it in standard form first. This will be equal to 0.76 then times 10 raised to power 9. Because here you have to move your point this time around to the right. Because the whole number is 0. You have 0 points, the other digits. So you move your point to the right in this case. Alright? And now we're going to move it one time because the point should come between 7 and 6. So this goes this way. Right. And this will be equal to 0.76. Then times 10 raised to power 9. I moved the point once to the right. So I am going to subtract 1 from the power. Is that okay? And if you do that, this is going to give us 7.6 times 10 raised to power 8. 0.7 is the same as 7. Now we have to get our answer in the nearest whole number. We can now say, therefore, 0.76 times 10 raised to power 9 is equal to, now, working this to the nearest whole number means you round off from tenths to units. From tenths to units, that's what it means. And if you look at the tenth digit, it's 6, so it's up to rounding up, which means we'll add 1 to this unit digit, making it 8. So this is 8 times 10 raised to power 8. You want to do it 8.0, the choice is yours, because once you round off any number, that number becomes 0. Times 10 raised to power 8. This is my answer. Please let me indicate here in 1 dp. And here in the nearest whole number. Please take note. If, like in this case, we are asked to round off to the nearest, round off to, that is correct to 1 dp. Here we are asked to correct to 1 decimal place. It means we are correcting to this tenth, 1 decimal place. Suppose this hundredth digit is not up to 5. Let us assume that this is 3.445. That this digit is 4 now. You know, you round down, which means your final answer will be 3.4. Again, look at this. Suppose this tenth digit, which you are rounding off to the units, nearest whole number. If this tenth digit is not up to 5, let us assume it is 4 or 3 or 2 or 1. You know that you have to round it down. And how do you round down? Simply make it 0. Cancel it off. Are you following, right? And this will just remain 7, which means the answer here will be 7 times 10 raised to power 8. Please, this just to remind you of what you've learned so far in our previous classes under Sacred Foundation of Mathematics when I taught you rounding off. In our next class, I'm going to teach you how to add and subtract numbers in standard forms. Get ready for that class. However, As usual, below this video lesson, you have your lesson notes. And below the lesson notes, you have the quiz to take on what you've learned in this class. Please, take the quiz and your target score, remember, 10 over 10. I hope to see you in our next class.